You're watching NASA TV.
Good afternoon, and thanks for joining us to discuss the upcoming U.S. spacewalks to continue solar array upgrades aboard the International Space Station. I'm NASA's Leah Cheshire, and today I am joined by Dina Cantella, Operations Integration Manager for the International Space Station, Anthony Varia, Spacewalk Flight Director, Fiona Turret, Spacewalk Flight Director, Keith Johnson, a Spacewalk Officer, and Chris Mundy, Spacewalk Officer. The spacewalk is scheduled for November 15th by NASA astronauts Josh Cassada and Frank Rubio, both on their first mission and first spacewalk. Cassada will be EV1 wearing red stripes on his suit, while Rubio will wear the unmarked suit. To tell us a little bit more about station operations and our upcoming spacewalks, I'm going to turn it over to our guests for some opening remarks. But just before that, if you have a question on the phone, please press *1 to raise your hand and *2 to lower it if your question has been answered. For opening remarks, we will start with Dina.
Hi. Thank you, Leah. Appreciate it. So first of all, thanks to everybody for being here and for tuning in. I appreciate that. Of course, our experts are going to talk about the 3 U.S. spacewalks that we have coming up, but I did want to, just for context, give you kind of a preview of the next few weeks upcoming on ISS, as well as talk a little bit about some reviews we've had with the spacesuit and spacewalks recently. So regarding the next few weeks, this is a really busy time on Space Station, and I know we say that a lot, but it's really, really busy. And so we've got a couple of major missions happening. We've got on the way to us actually is a Cygnus for Northrop Grumman 18. The mission has already launched, and it was a gorgeous launch. The Cygnus is doing well. It had an array that didn't deploy, and so Northrop Grumman is really working at it right now to get that array deployed, and of course we're assessing the capture and berthing in case it does not deploy. That capture is expected on Wednesday at 4:05 a.m. Central Time here in Houston. And so we're looking forward to that. That particular mission is bringing up one part that's critical for the arrays, or for the spacewalks, I should say. It is called a mod kit. It's a collection of brackets that the team will talk about here today that will go out on a solar array wing. The crew will assemble it partially inside and take it outside. And that comes up on Cygnus, so that's a key component. Then we've got the SpaceX 26 mission also later this month. So that is going to launch on November 19th is the current plan. And SpaceX is securing the range on that date, still working on that. Of course, that date was selected to give us enough time for turnaround, essentially, between the Falcon Heavy on the pad and then this particular F9. So, and we are watching for subtropical storm Nicole, which is out there, of course, headed to Florida towards the end of this week. So, as always, we're watching the weather as it evolves out of KSC. So. Anyway, so those 2 missions alone, even without spacewalks, they are really busy. And so there's a lot of science, a lot of cargo ops that are involved. Plus, and I've failed to mention for SpaceX 26 that, the IROSA arrays, the ISS rollout solar arrays, those are in the trunk for that mission. And so there's robotic ops associated with that. So a very busy time. In addition to that, we have 4 Russian spacewalks that are happening in the same time frame as well, and there is some shared equipment amongst the U.S. and Russian sides, and so we're very carefully choreographing all those operations. So a really busy time frame. So that's the context I wanted to bring to this. And then secondly, I wanted to mention, if you recall back in March, we had an incident where we had a crew member that after a spacewalk had water sheeting into the visor of the helmet. And so we had stood down from conducting nominal spacewalks while we did a thorough investigation. And we recently completed an agency-level review of all the findings from the investigation, and we are go for nominal EVAs. To say it was thorough was just really an understatement. The spacewalk teams, the spacesuit teams, they've really done an amazing job at really leaving no stones unturned to make sure that we fully understood what happened. And we brought the suit home that the crew member had actually worn and did a review of all the components and didn't find any hardware failures in the suit itself. And so the conclusion was that we had really had an accumulation of condensation that was just slightly above normal, and that accumulation then made its way from the vent loop into the helmet. And so the team has come up with some operational techniques for managing temperatures and that sort of thing in the suit to avoid that where possible, and then also some additional hardware, I'd say, absorption type bands were added to the helmet to keep the water from getting in the crew member's vision, or essentially to help absorb it if it were to try to sheet over the front. And so anyway, the team did a really outstanding job, and we are go for nominal EVAs. I'm really, really proud of the team for what they accomplished. And so on to the spacewalks that we're going to talk about today. We've got, for the first one, we have, as was shown already, but we have Josh and Frank as the EV crew members. And for the second and third EVAs, we'll announce those crew members as soon when we get a little bit closer. For the first spacewalk, of course, that has to do with this assembly of the mod kit I talked about. And also there's a really critical cable that we'd like to have installed as well ahead of the upcoming rollout solar array EVAs. The mod kit is specific to a set of arrays that won't fly until next year. And so we're targeting currently SpaceX 28. So the mod kit isn't needed ahead of the 2 spacewalks for the SpaceX 26 iROSAs, but we really want to install that cable to get ahead so that the iROSA EVAs have a really good chance of success. And so we're trying to get that done, and also it gives us a chance to test out our the new absorption pads in the helmet and some other, basically get the team ready for the really critical rollout solar array EVAs that are going to happen. So that first EVA was mentioned, that's November 15th is what we're targeting. And then for the second set of the next two spacewalks, we're targeting November 28th and December 1st. And those are tentative dates, I'd say. Of course, it's dependent on the SpaceX launch, and also just, that we have an evolving increment, as I mentioned, very busy, so we'll see how things progress. So for those 2 EVAs, those are rollout solar arrays 3 alpha and 4 alpha, and you're going to hear all about them, as our experts are going to tell you all about how we're going to do that. But I'll just say that from an overall program perspective, the solar arrays are really critical for augmenting the power, and you'll hear quite a bit about that as we go, but it's about 9 kilowatts per rollout solar array, so we're really looking forward to that. And so with that, I'm going to hand it over to our experts, and I'll kick it over to Anthony Vareja first, lead flight director for the first EVA.
Thank you, Dina. Yes, so I'm the lead flight director for the EVA that Dina mentioned is happening on the 15th of November, so next Tuesday, with the crew going out the door at a little bit past 6 a.m. Central Time. And so these EVAs are a two EVA effort to get these solar arrays upgraded. So you first set up the scaffolding, which is what we're going to be doing for the 1 Bravo power channel on next Tuesday, and then you add the iROSA array itself, which is what Fiona and other flight directors will be doing with further EVAs that those guys are going to tell you about a little bit later in this briefing. So this is about the setup. I think we have a graphic to show what the arrays are going to, what the current setup of the arrays look like with regards to how the iROSAs are currently positioned. Maybe we don't have that graphic, in which case I'll just tell you. Okay, there we go. So that shows the P6 truss right now. That's arrays on 2 Bravo and 4 Bravo. We have power channels 1 Bravo through 4 Bravo. 1 Alpha through 4 Bravo. And so those 2 channels out on P6 already had both EVAs done, both upgrades. And so those arrays are producing power, and that power is good for us because we like to make that power into great science on board. And so Josh and Frank, with Nicole and Koichi helping them on the inside, Josh and Frank are going to be going out and setting up the scaffolding to attach those arrays for 1 Bravo. So that's a great picture right there of what that scaffolding looks like. It's the protrusions on the bottom of the beta gimbal assembly, that barrel-looking thing at the base of the solar array, the traditional solar array. Now, those solar arrays have been up there for several years now. In this case, the ones on S6 have been up there since 2009. And those arrays are doing great for us and doing great science, but over time, just normal wear and tear they get used up a little bit, and some of those strings that generate the power on those arrays just fall offline. That's a standard thing that we have built into our power plans for years. And so looking at the 1 Bravo array and how it's degraded over time, we know that this one is a good one to go after to increase the capabilities for future usage. So this graphic shows exactly kind of the playbook that we're following right now, with 2 Bravo and 4 Bravo on the port side completely done. 1 Bravo is what we're going to be going after next Tuesday to add the mod kit, and then the mod kits have already been added to 3 Alpha and 4 Alpha. We'll swing back in January and add the 1 Alpha mod kit in a future EVA, and then those 6 arrays will be set up and ready by middle of next year. As Dina said, the 1 Alpha and 1 Bravo IROSAs will be coming up around that time. So that extra science and that extra power is really useful for our operations on station. As we look towards next Tuesday, the teams are getting ready. The flight control teams and the crews are getting ready with the launch of Cygnus this morning. That solar array material, the scaffolding, as I mentioned, the mod kit is on that Cygnus, currently en route to the International Space Station. So we're looking forward to capturing that Cygnus and getting to unpack it and put together those mod kits for a bag that the crew can take out and start setting up the arrays next Tuesday. They're familiar with it on the ground from the ground training that the excellent EVA folks have done here, and now they will be able to take advantage of that training to execute an excellent EVA next Tuesday. Further EVAs, as stated, will be tackling other parts of the ISS power system, and I'll hand that over to Fiona to talk about what she's going to be doing out a little bit further.
Awesome. Thanks, Anthony. My name is Fiona Tourette, and I'm one of the 2 flight directors who will be the leads for the IROSA install EVAs at the end of the month. As mentioned, we'll have 2 spacewalks, both to install the ISS rollout solar arrays. Those will be on channels 3 Alpha and 4 Alpha. So that scaffolding or the mod kit that Anthony and Dina have talked about, that's already in place for these EVAs. Those channels are ready for the solar arrays, and those will be coming up on SpaceX 26 in just a few weeks here. We've previously done 2 similar EVAs to install the IROSAs, as Anthony showed on one of our trust segments. Those were done last summer of 2021. So we'll be the 3rd and 4th installation of these arrays. Our team has done a really great job incorporating lessons learned from those previous 2 arrays. We've done simulations as well as run this spacewalk in the neutral buoyancy lab. So the crew members on board as well as our ground team are well prepared, and we're looking forward to being able to go out the door and help augment the science capability of ISS with this new equipment. As has been talked quite a bit, each new array brings new power. ISS continues to grow. We have more science and more systems online. And this additional power will help ensure that we can operate ISS to the fullest extent in the upcoming years. So as Dina mentioned, the spacewalks are planned for around the end of the month. The first one will be November 28th is our projected date, followed by December 1st. Of course, as time gets closer, we'll make sure that that's still the best date for the plan. The 2 spacewalks are very similar. We're going to different sides of the vehicle. As you saw on the graphic, 3 Alpha and 4 Alpha are on opposite sides of the vehicle, but the overall flow of the spacewalks are pretty similar, where we're getting an array, bringing it out there, and then getting it fully electrically mated and then deployed. The crew roles are still to be announced, but I do want to point out that this is an EVA that involves the entirety of the crew members on ISS. So Nicole, Josh, Koichi, and Frank will all be extremely involved, whether that is out the door in the spacesuits or inside helping with the airlock and spacesuit operations, and then flying the robotic arm. We will have a crew member on the arm for the spacewalk, and so their crew members inside will be flying that arm and making sure that they are safe and where they need to be to do the work. So it will be a all hands on deck day for both those spacewalk days with all crew members helping make this successful. On the ground, Nick Haig will be our ground IV. He will be the person talking to the crew members outside, making sure they know where to go and what to do. Nick is an experienced ISS crew member and has done spacewalks himself as well. And then Chris Mundy, who you'll hear from a little bit later, is our EVA officer in mission control. So with that, I will hand it over to Keith. He will talk a little bit more of the details of next week's EVA.
Thanks, everybody. It's a great setup. You've heard a lot about what we're going to do on the EVA coming up. We are the 5th of the mod kits to be installed, so we've done a number of them already, and you're wondering to yourself, well, how is this different than any of the other mod kits? Well, it's exactly the same. The assembly inside is exactly the same. The bag that we'll use to take the hardware out is exactly the same. So what are the differences? Well, in this particular case, we are returning from what Dina was talking about, where we had suit issues, and we did a lot of work on recovery and planning, and we are sending out new astronauts that have never done a spacewalk before. So this is a good opportunity for them to get outside and do a fairly straightforward assembly task. Frank was the ground IV for the first set of mod kits that we installed, so he has a very good background understanding what we're doing with that assembly process. So, but one big difference is that we have a fixture on the side of the solar array blanket box that is a fixture that is used by the robotic arm to grapple the solar array if it were to be jettisoned. It's no longer needed for that, and it gets in the way from installing this mod kit. So we have to remove that bracket. We've done it before. We have not had a problem with it before, but we're doing it during the EVA where we're going to install the mod kit. That's the first time we've done that. That's a little different. There's no higher risk, no big difference, just that this particular time that has to be removed in our EVA. The other thing is we're kind of the building blocks, as we all mentioned, about the scaffolding where the solar array is going to be installed. So we're kind of the backbone for that. And we want Chris and his team to have every opportunity to get these EVAs done in the time frame that we have allocated for an EVA. So because of that, Dean already mentioned, we're going to install one of the cables, and that will help Chris's EVA get done hopefully within the 6.5-hour time period that we normally associate with EVAs. So it will give the crew members an opportunity to do an EVA hopefully before they have to go out and install an iROSA, which is a lot more challenging. And we'll hopefully get the cable installed so they have a little bit less to do on those EVAs. So with that, really we're just part of the whole process to get these solar arrays installed, and we hope to make a clean runway for the solar arrays that are going up next year, and we hope to get Chris and his team ready, and Fiona, his team ready to get these iROSAs installed. And with that, I'm going to turn it over to Chris.
Great. Thanks, Keith. Thanks, Fiona. So my name is Chris Mundy. I'm the lead EVA officer for the second and third EVAs in this series, the 2 iROSA install EVAs. As was mentioned earlier, the primary objective here is to install 2 brand new solar arrays out on the outside of ISS. Those arrays come up, launched in a SpaceX vehicle. They get launched, they're attached to a carrier, they're folded up and obviously not deployed yet on that carrier. And so our EVAs take them off of the carrier out to the installation location, and then secure them, unfold them, deploy them, and integrate them into the power channel. So as Fiona mentioned, our EVAs, the 2 EVAs are very similar to one another. On the first EVA, we head out in the starboard direction, where we'll head out to the 3A installation location. And then on the second EVA, we'll head out to the port side of the vehicle for the 4A installation. Our EVAs are kind of broken up into 4 separate chunks of time. The first chunk of the EVA is we'll come outside and we'll start to prepare everything. That means we have to go prepare our work sites. We transfer bags from the airlock all the way out to our work site on the starboard or port side of the vehicle. We'll then work to release some bolts and tie-down mechanisms that held the arrays in place during the launch. We'll also have a crew member setting up the robotic arm. They'll be installing a foot restraint onto the robotic arm, and that will help us later on as we carry the array from the carrier all the way over to the mod kit location. Once we're done with the prep, that's when the real fun begins. That's when we get to actually pull the array off of the carrier. And so we'll have one crew member in the robotic arm, in the foot restraint, and we'll release the last bolt holding the iROSA onto the carrier, and we'll pull the array off, and we'll use the robotic arm to fly us over to the mod kit installation location. The free float crew member, the one not in the arm, will head over, meet up, and the 2 crew members will work to install the arrays onto the existing mod kit. Once we have it there, we'll be able to unfold the array, so it's actually hinged, and we have to unfold it onto the mod kit, and then secure it with some structural bolts. After that, we get into our third chunk of time, which is now electrically integrating the new array into the existing power system on ISS. So to do that, we have to install a couple of different Y cables that get installed. Once those are fully connected, we will be able to route power from the legacy array and the new iROSA array into the ISS power system. Once it's electrically connected and structurally connected, we're now good to go deploy our array. So we'll get crew members in a position to view the deploy, and we'll release the last 2 bolts holding it down, and we'll deploy the array. That whole process takes about 6 to 10 minutes as the array unrolls and unfolds up to its full deployment position. After that, we get into our final, our home stretch chunk of time here, and that's our cleanup section. And so we'll pack up our bags, we'll clean up our tools, we'll head back inboard on the first EVA. We'll do some get-ahead work to help prepare for the second EVA by removing some launch beams that were holding the first array in place. That gives access to the second array. Once that's complete, we'll head back into the airlock, get the crew safely back inside, and we'll get ready for our second EVA. Our second EVA, as we mentioned, is just going to be a repeat of those 4 things. So we'll go out, we'll do our prep, we'll remove the iROSA from the carrier, install it on the mod kit, route the cables, electrically connect it, and then deploy, and then we'll clean up and come back inside. We'll be done with our second EVA. So after that's complete, after 2 great EVAs, we'll have 2 new shiny iROSAs installed out on the outside of the space station with increased power generation capability. Thank you.
All right, thank you, everyone. We're going to move into the Q&A portion of today's briefing. So again, if you're on the phone and you have a question, please use *1 to raise your hand, and *2 if you hear your question has been answered. Additionally, please state your name and affiliation and to whom your question is directed. Do we have any in the room to start? Okay. Start with 1.
Let me start with Dina. We knew if Cygnus hadn't launched, clearly you would have had to probably push this back. How much is supply chain issues a challenge for you in maintaining the space station?
Well, when we have delays, we start to look at our, our consumables and our capability, and right now we're doing okay. We do want the Cygnus mission to get there. It has, amongst other things, it has things like the crew's food, it has wipes, it has a lot of regular consumables from an everyday standpoint. So we are looking forward to having Cygnus arrive. So, but of course, we're always keeping an eye on that, and we have reserves just for that reason, to make sure that we always have enough supplies. We do some sharing with the Russians as well, and so, they're monitoring our vehicles, we're monitoring their vehicles, and we just had 82 Progress that just docked, and so that's helped with things like food and wipes and all those consumables as well. So, in terms of supply chain problems, if you're talking about hardware supply, of course, that is an issue all over industry, and so that is also something that we keep an eye on for hardware development. And right now, we're not having any issues that, to speak of, just in other words, in terms of all of our critical replaceable units and that sort of thing. But we are keeping an eye on that. We're working with our vendors who, as all across industry, they have problems with those types of things. So we're keeping an eye on things. Right now, everything's holding together, though. I appreciate that question.
And for Fiona, the iROSAs, do you anticipate those will eventually replace the current solar arrays, or are they're a supplement, but a critical supplement? What's the long-term plan on that?
The long-term plan is that they are a supplement. So the nice thing about them is that they kind of soften the picture. They cover part of that old array, but not all of it. And we're able to use the power that is still generated by the parts of the old array that aren't covered, in addition to the power generated by the new array. And so the old array is still generating power. Obviously, it's been up there for quite a while, as Anthony was mentioning, and over time you lose some capability, but it's doing quite a good job. And so the goal is that the iROSA will work together with the with the old array for the rest of the station life to together power that power channel.
And one more, Keith. These are both first-time spacewalkers. It's happened before, but is there a particular challenge when you face a situation like this?
No, we do the same training for all of them. Sometimes we count on that experience for especially challenging EVAs where we send a crew member that has the experience. So Under these circumstances, we don't have any question that these are competent crew members to do the job. It is just good that they can use that experience on future more challenging EVAs. So from our perspective, we're very comfortable with their performance in doing this EVA for a first-timer.
Okay, thank you. We will now move to the phone bridge. We'll start with David Curley of the Discovery Channel.
Thanks very much. I have a couple too, like Gina. First of all, back in July of last year, you said all of these arrays would add about 30% power to the station. Is that still the case? Have you changed anything with the bolts, the mod kits, any connectors after the experience of putting the first arrays out? And then is the suit back up, and can you give me a percentage of the additional absorption material added to the helmet in a percentage, I guess, versus square inches?
Okay, why don't we share that response for a moment? So I'll just say for the amount of power generation, yes, nothing has changed with that. We are expecting, as I mentioned, about 9 kilowatts per IROSA array. And so with 6 additional arrays, you can multiply that by 9. And then I'm doing some quick math in my head. But, if we start at 165 kilowatts, maybe 30 or so percent is probably about right in terms of what we would add. And then let's see, in terms of, what the absorption bands look like, essentially they're just like a thin piece of absorption material in a couple of different places in the helmet. And so they're actually orange, and so they'll be visible in videos as you see the crew preparing for the spacewalk. And then they essentially just, adhere. It's a temporary piece of the equipment that's in the crew member's helmet. So, I'm not sure if anybody has any dimensions, but maybe a couple inches wide is one of the bands, and the other band is similarly about that wide. So, but it is very it absorbs a lot of water, and so we actually did some on-orbit testing, and we've taken several different models of this up, and the crew on board sloshed water around, essentially tried to inject water into the helmet at the same rate that would be kind of a worst case, and we found that these pads were very, very effective. And they basically supplement, if you remember, back in 2013, we added a helmet absorption pad that's much thicker, and when we supplemented it, it turns out there's a little bit of kind of a sneak path, and so we're just really kind of trying to get that sneak path covered with these very, very thin bands of material that we're talking about here. And then let's see, there was a second question. I was going to pass it.
I can take the second question,
Okay.
But I'd also like to supplement your supplemental question
Okay.
there about the hat. And that is that new band that you mentioned also allows a crew member to position their head and look to see discoloration too. So the HAP that we had before, we relied solely on the crew member leaning their head back and determine if it's squishy from water or if they could feel a different cooling with that pad. And we did a lot of testing beforehand using that to see what that sensitivity was. And we feel like when this happened on US EVA 80, they didn't quite feel it the way we had hoped they would. So now the additional ones give you some kind of a visual verification that you could see a discoloration of that. And then there is also the additional pad back there to collect more of the water just in case. So these new additions give us a little bit more confidence that we'll determine the water collection. We've changed all our procedures on how to look for it and how to act when we see more water in the helmet. So that helps. I think the second question that you asked was about any differences in bolts, and I can say, or torques or turns, from the mod kit standpoint, it is exactly the same. The big difference, though, is that when we take off this last H fixture, we are concerned, yet again, same as we were before, that if something happens with one of these bolts, should we continue with the assembly of this particular mod kit? And we're in a good position. Anthony and I have talked this over and planned it with the team on how we want to react if we have a problem with the bolt. So there shouldn't be any new surprises. We're just prepared for everything that could happen. And I think the third question is for you guys on the solar arrays.
Yeah, absolutely. So with the IROSAs, during last summer's IROSA install EVAs, there were some issues unfolding the array. And what was happening is as we were unfolding the array onto the mod kit, there's an alignment guide that fits into a receptacle on the IROSA itself. and those were making contact. The clearances were such that we couldn't physically unfold the array. And so we had to get a little creative, and we were able to solve those problems and fully install the array. On the ground, for the next set of arrays, we've hopefully solved that problem. We've expanded the slot that's on the iROSA itself so that the clearances should not be an issue. So when we get out there and we unfold our arrays this time, we expect them to fully fit inside the alignment guide.
Again, I'd like to supplement to that as well. So with the first set of solar arrays that we flew up, we were in COVID times. And so there was no getting to see the flight hardware during assembly, see any of the deploy sequences or anything like that, because everything was pretty well shut down. We were lucky that they continued and could build the iROSAs in time, but that did not afford us an opportunity to go see a lot of the testing that helps us as a team get ready for these deploys. And when that happens, it leaves a door open for a lot of doubt and a lot of concern. And we saw it during the EVAs last summer. So we had to react the way NASA does and solve the problem and fix it real time. But it then leaves that feeling like, how is this going to work for all the rest of them? So Chris and his team picked up after our iROSA deploys last year, and immediately they jumped on those problems and came to the solution with the hardware provider to fix the problem. So it's just great to watch NASA and develop a plan, fix a problem, and then be prepared for the next time. So Chris and his team were able to go look at the hardware and do some of the deploys and the new testing that they didn't do for the first set of iROSA. So it's very encouraging to watch us get better and better as we go.
Thank you. Next on the phone, we'll go to Bill Harwood with CBS News.
Hey, thank you very much, guys. This is a question for Dina, I think. And Dina, I realize this probably isn't your primary responsibility here, but can you give us a better understanding of the status of that second Cygnus array? I mean, is it partially unfurled? We don't even know that. And I also appreciate a little bit more about what sort of loads issues or analysis is required before you would capture and berth a Cygnus if one array is not fully deployed. And are there any issues with staying full duration and then departing in that condition? I'm just not sure I understand what the loads issues are. Thanks.
All right. Well, Bill, those are exactly the questions we're working through right now. I will say that Northrop Grumman is prime right now. We're not even in integrated operations until tomorrow, around 11 a.m. Houston time. But we are working closely with them. And right now the array is not deployed, and it goes through some stages of deploy, and it is not deployed. And so the team is trying to assess the data that they have right now, I'll just tell you, and figure out their next steps. So I'm kind of giving you kind of a general answer at this point because really, like you said, it's very new, and Northrop is primary for those types of questions, really. Now, can we capture and berth in this configuration? We are absolutely looking at that, but I don't have a status of that. We really are not even sure the configuration that we're talking about yet. Our teams are going to be concerned about, there's different, like I said, there's different stages of the deploy. So if it ends up partially deployed, then it could, I'd say, jiggle upon capture or berthing, or it could come open. So those are the types of things and risk assessments that we'll be doing if necessary as it approaches. Of course, we'll get great viewing when it gets closer to see what it looks like. But again, I think that it's really early, and I'm very hopeful actually that Northrop is going to find a way to deploy the array fully. And so, I think that we have a really good chance at getting there long before we enter integrated ops with ISS.
All right, thank you. Next question is from Marcia Dunn with Associated Press.
Yes, hi. Dean, I have some more Cygnus questions, if you don't mind. I'm just wondering, as things stand now with only one array deployed, that's enough power for the Cygnus to get to where it needs to go. Is that correct? And then it's a matter of how unstable it might be if only one array remains open. I think that's what you're saying. And how long could the capsule loiter in the neighborhood for a while if it's not ready to be grabbed on Wednesday, and how much time could it just hang around waiting? Thanks.
Okay, well, first regarding power, I know that it's doing well right now. And then the team at Northrop, and then of course we'll work with our NASA team as well, but we'll assess as it goes through the various orientations on its way to ISS, will the power be acceptable? And so of course we'll be looking at that, and we'll be looking at its duration on ISS. And then how long can it loiter? You know, there is enough propellant to perform at least one re-rendezvous each mission, and so we have that. And so where you actually decide to sort of hold the vehicle determines how much propellant you use. And so we have not yet worked through at all where we would have a vehicle hold or how much time we would have if we had a different type of a rendezvous, or maybe, you know, held it for longer periods of time. And like I said, that would vary depending on where we are in the rendezvous. So we're all working on that right now. But like I said, I am pretty hopeful that we'll get the other array deployed.
Thank you. Next question is Marcia Smith, Space Policy Online.
Thanks so much. I'm wondering, are all 4 of the U.S. segment astronauts trained to do these EVAs, including Koichi Wakata? And is there special training for astronauts that are going to be doing these EVAs standing at the end of the arm versus being closer to the space station? And I had another question for Dina. I was wondering if she could expand on what she said about how there's shared equipment with the Russians. And so, you know, the fact that there are all these 7 EVAs all taking place, you know, how much is shared and how much support does each side provide to the other? And is there some sort of pacing item, like a beta angle cutout or something, that's causing all of these EVAs to happen in such a short period of time?
Okay, well, there's a lot to unpack there. Maybe why don't I'll start it off, and then I'll pass it over to the EVA officers. But yeah, there is actually a beta angle cutout, and it is affecting both the U.S. and the Russian EVAs. And so right around December 7th or 8th, thereabouts, it starts to increase in our solar beta angle, which is, you know, essentially an angle on the space station, and that makes it more difficult. As an example, for our for our U.S. EVAs, it changes the sun's angle. So there's, you know, portions of the workspace that could be in eclipse versus in the sun, and it also changes the way the solar arrays are angled. It could change, you know, whether we have risk of shadowing one of our longerons, and so those are the types of things that we get concerned about as our beta increases, and we have about, you know, 10, 12 days or so in December where it's not as good. And then I know that our Russian colleagues also are concerned about beta, maybe for other reasons, like thermal reasons. They're actually moving a radiator, and they're moving an airlock in a couple of their spacewalks, and so it's important for them as well. And so I know that we're each trying to time our spacewalks sort of around that. If we can, we would like to get the U.S. spacewalks completed prior to that high beta, so as soon as they arrive, we would just deploy them as soon as we can. Let's see. So I've forgotten the other questions here.
Let's see. So from a crew training perspective, we start a standard set of training that we give the astronauts when they get assigned to a mission. And it's a certain number of runs where we practice our critical contingency EVAs, so they know how to fix critical boxes on board space station. And then we have a subset of those total number of runs that are specific to the EVAs that may be happening when they go up. And in this particular case, we've known these 4 crew members would be up there several months ago, and we started looking at what is in the plan, what hardware gets up there during that time. So they all received training on all of the content that's coming up on these EVAs. So then what happens is there's an evaluation and a looking at what the content of the EVAs are, and would it be suited for someone perhaps better than somebody else, like arm length sometimes plays a part of it. But for these particular crew members, they all are capable, fully capable of doing all of these EVAs. And so it really is just a fine tuning to figure out what activities they have on board space station, what the EVA takes away from, and it's a balancing act for the planners and for the lead flight directors to figure out which crew members are going to be doing the spacewalks.
Did we answer them?
The piece about is there different training for a crew member being on the arm? When we do their training on the ground, they rotate what roles they're doing in that training. And so the overall training really covers all the different roles they could play. And then as Keith was saying, once we know, okay, these crew members are likely doing these spacewalks, we have them perform the different roles in their training. And so the crew members have all had experience working with the different roles, including being on the arm for these EVAs.
All right, up next on the phone, we have Mark Hero, Aviation Week in Space Technology.
Thank you. I have a couple. If the Cygnus freighter could not reach the space station because of the issue it's that you're working to resolve with the solar panel, would you proceed with spacewalks with perhaps different agendas, or would that kind of call a halt to this spacewalk campaign for the iROSAs for a bit? And I wonder if you could name who at least tentatively assigned to each of these 3 spacewalks.
I'll take those. So first of all, if Cygnus doesn't arrive with the mod kit, then we probably don't have time to change up and do an EVA of another content prior to SpaceX arrival and the iROSA EVAs. And so we would consider, of course, jumping right into the iROSA EVAs at that point. That's where I think we would head. But of course, we'd have to assess that, and that's a what if that hopefully we don't get to that point. I've already forgotten the second question. I apologize. It was, who's doing the EVAs? Well, so again, we don't like to name them in advance because we have to look at the overall crew time. As I mentioned, we have a lot of payloads happening and who's actually assigned to do what payload, and that kind of depends on which vehicles are there. And it also, is a matter of crew sizing, and we have suit issues often that might require a resize or that type of thing, and so that could change the crew members. So we hesitate to talk about that because we might have real-time changes and things evolve. In any case, like we said, they're all trained to do that, and so we're kind of looking at it one EVA at a time.
All right, and we have a couple of questions on social media. This one from Shani, who wants to know, how does the spacesuit work in extreme temperatures that the astronauts experience while outside the space station?
Sure. So inside the spacesuit is a whole system dedicated to keeping the crew member at a reasonable temperature, a workable temperature. That system involves the internal liquid cooling ventilation garment that runs water through kind of a set of pajamas underneath the spacesuit that either provides cooling water or helps remove excess body heat and uses a sublimator system to expel that heat overboard. So that keeps the crew member thermally comfortable within the suit. The outside of the suit is designed with TMG. It's a thermal garment that's on the outside that helps reflect off heat or retain heat into the suit. So the outside of the suit helps keep the inside at the right temperature, and then within the inside, we help keep the crew member at the right temperature using that water and ventilation system.
Okay, thank you. We'll go back to the phone. Another from Marcia Smith with Space Policy Online.
Thanks so much. There was one part of my question that didn't get answered before. I know it was a multi-part question, but I was wondering if Dina could expand on what is it that we share with the Russians. You said that there's shared equipment. What kind of equipment is that, and what else do we share with the Russians on these spacewalks?
Well, I'll give an overview, and then of course we can supplement with our EVA officers. But we have helmet cameras, and we have things like tethers, and a lot of actually U.S. equipment that they use on the Russian spacesuits. And so, as part of that, it's not just a matter of just toting it down to the Russian segment and having them install it on the Russian spacesuit, but we have to charge batteries for some of our equipment as well. And so we have to, like I said, choreograph that and make sure that we have enough time to charge it. Is it charging overnight? Do the crew members have time to insert the batteries into the charger and take it off of the different helmets? And so we're actually hoping to pre-stage, one set of equipment on one of the Russian Orlan spacesuits, so that all we have to do is kind of bring one set back and forth for the helmet. And then maybe we can loan them some tethers for their series of EVAs. And so, I think that the details are these guys down here, so maybe you can add to that if you'd like.
Well, it's interesting because, you know, two completely different parts of the world develop their EVAs completely differently. And but it's the same environment, and you're leaving to go out to do something very dangerous that you want to keep safe. So we share back and forth on what they have learned from their spacewalks and what we do on ours. And what's interesting is that the technology that we use to build these helmet cameras, we're now high def. And yes, we're way behind the rest of the world on what high def is, but it takes a long time for that hardware to get developed and to finally get outside and be certified to go outside. So the Russians see our helmet cameras and they say, wow, that's way better than anything we've had. And so we find a way to negotiate with them to use that hardware back and forth. And we use some of the things that they had, like the wire ties, which seem so simple and yet provide a really great way to restrain things very easily when you're out doing a spacewalk. So we go back and forth. The tethers are very important, and we have very good tethers that we use to restrain every piece of hardware that goes outside. They do as well, but they see the benefit of using the special hooks that we have that are perhaps easier to use in a glove than some of their hooks. So the shared hardware really makes both EVAs safer and more efficient, and that's exactly what you want to do when you're trying to keep humans safe to do these events.
All right, we have another from David Curley with the Discovery Channel.
Dina, there was some in the blog post about the suit and Mauer's suit and what was going on. It sounded like he was exerting himself and the cooling setting wasn't right. So can you get into a little bit of details of what you'll do in the future? How do you know if somebody's exerting themselves? Where do you put the setting to cool so that you don't get this condensation?
Well, first I'll just say to maybe soften your thinking a little bit. You know, every crew member is different. You know, one person may go to the gym and sweat more than another person or less, and so just in general, I wouldn't say that there was any overexertion or anything unusual about what happened on that particular spacewalk. Sometimes the conditions just lead to additional condensation. So there's different, I'd say, places that the condensation comes from, and the cooling setting of the crew member is pretty important. And so we're trying to make sure that operationally we work with the crew on trying to be as neutral as possible. We can't get too cold, we can't get too hot for various reasons in the suit. And so we're kind of refining that, I'd say, and that's some of the operational techniques. Again, I'll pass it over to my EVA officers.
What I find interesting is these questions can all go to Dina because she was an EVA officer and a flight director and fully capable of answering all the questions that we get thrown our way. But that's a really important point to make, that each individual goes out in that suit. And for these particular crew members that we're sending out on the EVA coming up next week, this is the first time they will have been in that environment. They've trained in the suit, they've done vacuum chamber runs, but this is the first time where they're under the thermal environment that actually tests, you know, how cold they get or how overly warm they get. And to be able to react to that in the suit requires that they reach down to their temperature control valve and sort of anticipate the environment that they're going into, whether it's going to be overly warm or overly cold, depending on the beta angle and depending on where they're working on station. So we are monitoring their metabolic rate, which affects how much heat load they put into the suit. We're monitoring their oxygen consumption, and we have surgeons on board that are monitoring their heart rate to see how they're doing. But a lot of it is that particular individual and how they feel in the suit and what they want to do to anticipate. So now we're monitoring when they change their temperature control valve. We've asked them to report that to us. We'll take that into account, but it's really very difficult for us to anticipate what somebody's metabolic load and how much they put onto the suit during their EVA. But we learn and we try and react as best we can.
All right, we have another one from social media. This one from Swapnil. How are astronauts protected from micrometeoroid debris while they're outside on a spacewalk?
Yeah, so there's a couple of things that we do. Prior to our spacewalk, we'll do an assessment and make sure that we're within an acceptable range for debris. That means we look at the expected forecast where we think, if we think there are going to be issues, we look at that risk and assess it to make sure it's within our experience base. And then second, the spacesuit itself is designed with multiple layers of material that help protect against any sort of small debris impacts. And then the suit itself is able to withstand a certain size hole within the suit using its supplemental oxygen to be able to feed the leak that would be produced by such a debris strike and allow the crew members to get back to the airlock in a safe manner.
And our trajectory officers are always in touch with our DoD counterparts to make sure they're monitoring the skies for any traceable debris that could be found in the same way that we do every day on station. And sometimes we have to do those pre-planned debris avoidance maneuvers. We're always looking out for those, especially around EVA time, for the items that might be so big that we would want to actually fire the rockets to get out of the way of those debris items.
All right, thank you. It looks like that's all of the questions that we have for today. We thank you again for dialing in, and we look forward to you tuning in on November 15th to watch this first spacewalk. NASA TV will start at 6:30 a.m. Eastern Time. Thanks again, and we will see you then.